Here's our first example with projectile motion. So press pause, do your best to work through it, and then press play and we'll go through it together. Okay, well I'm going to start by drawing a picture. And in my picture I'm going to show that this object is it's driving off of here horizontally, and then it lands somewhere over here. And I want to know both where does it land, how far away is it when it lands, and what's the speed when it lands. So I really want you guys to try to treat these like normal kinematics problems, where remember our general strategy when we were solving a kinematic problem was to try to identify the value of 3 kinematic variables and identify the 4th kinematic variable that we're trying to solve for. Then you choose the equation that has those 4 variables in it, and then you solve. We're doing the exact same thing here, except we have to separate our x components from our y components. Okay? So I'm setting up here, my 0 event is going to be when it leaves the cliff. My number 1 event is when it lands. I filled out as many variables as I can. Let me just point out that the cliff, we're driving off the cliff at this speed of 20 meters per second because the cliff is just horizontal. They don't tell us the cliff like angles upwards or anything like that. All of that initial 20 meters per second is in the x direction. So my initial velocity in the x direction is 20. My initial velocity in the y direction is 0 because all of that velocity is in the x direction. Okay, so here I've filled out as much as I can. I want to figure out delta x. Ultimately, I want to know what x1 is. That'll answer that first question. The problem, why does that keep happening? Sorry, don't look. Sorry. Oh my gosh. My computer goes crazy sometimes. Sorry. Okay. The problem is I cannot figure out what delta x is until I know what delta t is. And because in the x direction I don't know delta x, I know my v, but I don't know delta t. In order to solve for delta x, I have to figure out delta t some other way. So I'm going to figure out delta t by looking in the y direction, okay? Because delta t is determined by what's happening in the y direction. Well, what do I know about the y direction? I know my displacement is -10. I know my initial velocity is 0. I know my acceleration. So I already know the values of 3 kinematic variables. That's going to let me solve for this 4th kinematic variable, delta t. So I choose my equation that involves those 4 variables. I plug in the values, and I find that delta t is 1.43 seconds, which means the object is in the air for 1.43 seconds. Now that I know delta t, I can find delta x. And I can I can say I'm trying to solve for delta x. I know my initial velocity in the x direction. I know my acceleration in the x direction is 0. And now I know delta t. So I can choose my equation that involves those variables, plug in the values, and solve. Okay, so that's my position. That means I'm 28.6 meters away from the cliff when the car lands. Now to find my speed, remember what speed means. Speed means the magnitude of velocity. So velocity is a vector. I want to know what's the magnitude of the final velocity. And the only way I'm going to be able to figure that out is to figure out the x component of my final velocity and the y component of my final velocity. Once I have my x component and y component, I can figure out the magnitude, which is the speed. Well, the x component of my velocity doesn't change. It does not change because my acceleration is 0. So I know the final x component of my velocity is 20 meters per second. Now I want to find the final y component of my velocity. So let's try to solve for that. I want v1y. I know v0y, that's my initial y velocity. I know my y acceleration, and I know delta t. So I can choose the equation that involves those 4 variables and solve for the unknown final y velocity. Now that I know my final y velocity, again, my final x velocity is just 20 because it doesn't change. Now I can find my speed. My speed is the magnitude of my velocity. So that's the square root of my x component squared plus my y component squared. There's my x component, there's my y component, and there's my speed.